Good afternoon, and welcome to the Alfred University Bergren Forum. My name is John D'Angelo, and I am the host. I am a professor of chemistry and the host for the fall 2024 season of the Bergren Forum. Welcome to episode 1. Today's date is Thursday, September 5th, 2024. And for those of you attending the forum online here in Western New York, it is a beautiful, sunny and mild day. But inside Nevins Theater of the Powell Campus Center, it is cozy and the coffee and tea are hot and free. Before starting, we have a few announcements. First, next Thursday's forum will be given by Eben Levy. Eben's talk will be on Padres y Pistolas, Radical Catholicism, and Revolutionary Movements in Cold War Mexico. There are some other announcements this week to announce. Namely, later today in Slideland 114, there will be a Fiat Lux interest meeting from 6:10 to 7 p.m. The Fiat Lux is the campus newspaper. The opening reception for Gina Colosimo's What Lies Within exhibit will take place in the Robert Turner Gallery tomorrow from 6 to 8 p.m. Also tomorrow from 12:20 to 1:10, the first Women's and Gender Studies Roundtable will take place in the Herrick Memorial Library Book and Lounge and will be a voter registration and training resources event. Finally, there will be a business, history, and art history courses in Germany this Allen term. For more information, contact the Study Abroad office, Professor Mark Lewis, or Professor Andrew Kless. The deadline to apply for education abroad is September 17th. Today's forum will be given by a dynamic duo of Coral Lambert, Professor of Sculpture, and Elizabeth Matson, Associate Professor of Mathematics, both here at Alfred University. The title of their multidisciplinary talk is Math, Crochet, and Sculpture. The floor is yours.
Thank you for joining us today. We're really excited to share our research. We didn't plan it, but actually we're both wearing polka dots and stripes, if you do notice. So the collaboration in my book was a success. We've come together in one way. So I am Coral Lambert, Professor of Sculpture.
And I'm Elizabeth Matson, Associate Professor of Mathematics. And yeah, this is our presentation and presenting forward what we made possible, what we created together and was made possible through the Catalyst Grant. So what the Catalyst Grant is it is a grant aimed at encouraging faculty to collaborate. It takes one professor from the College of Liberal Arts and Sciences along with a professor from the School of Art and Design. You apply together to receive funds of $2,000 to create this project over a one-year span where you're taking your individual fields and seeing how they come together, how they intersect into some undetermined project with some scope to it, of course, but the aim is to develop the final project as you go. And we'll talk more at the end of the presentation about how others can apply for this grant as well. So first off, to start out, I wanted to explain my work, where the inspiration came from, and how we were going to take my smaller pieces and turning them into, ultimately the goal was an 8-foot diameter sit-in sculpture, which we'll get into more. And so on the left here is the first piece of math art I had exhibited at the Bridges Math Architecture and Culture Conference. That year happened to be in Finland. No complaints on that one. And what I made was a skirt where I crocheted this hyperbolic plane that was to become a wearable piece of a mathematical concept. And then on the right is my piece from 2 years ago that was in Nova Scotia, exhibiting a hyperbolic pseudosphere shape. And it actually illustrates my mathematical journey of kind of realizing I liked math to then ending up a professor at Alfred University. And this was the beginning point of thinking, okay, looking at this structure, could we then scale this up and have a person sit right here with their back on the middle kind of cone portion and their feet dangling off the end, right? Could it be envisioned that this little 1-foot model could then be an 8-foot wide model and something that could be experienced, something that could be comfortable for someone to sit in? And the idea of crocheting hyperbolic planes was first coined by Dinah Tumina, a professor at Cornell University. And the concept just comes down to you pick a value for K and you do K single crochet stitches, and on the K plus 1 stitch, you add a stitch. And what it allows the piece to do is to grow in this rippling manner to exhibit an exponential type growth to the number of stitches, creating what is known as a hyperbolic plane. And so one example here is if K was 3, we're increasing on every 4th stitch. So if we started out with 8 stitches, next row we're going to have 10 stitches, having 2 increase points. Next row, we're again adding 2 stitches because we don't do any partial stitches. That's not possible in crochet. And from there, then the 4th row, you add 3 stitches because you've got 3 different increase points, and going up from there.
I come from a background in making steel sculpture and also cast metal sculpture. So to work in crochet was not my area of expertise, to say the least. My first little try of crochet with Elizabeth, because we did do some skill sharing, was not something that is going to be in this presentation. So, but when I work with steel, I work very spontaneously, and I chose to show this piece, which is actually, you might be familiar with, it's on campus, it's called Fallen Sky. And here I'm using a, almost like a quilting technique, where I put in the plates of steel together. I'm using welding as stitching. So sometimes in this piece, you can't see any of the welds. In other pieces, you'll see that the welds actually are like a cross stitch or a blanket stitch. So when Elizabeth approached me with this idea to collaborate, I was pretty excited to see how we could bring those two disciplines together. To create some of my sculpture, I actually do start with a soft, what is called a pattern. So this one is these foam lines, which I've spiraled, and then I'll take a mold of that and then pour molten metal into it. In this case, aluminum, other times iron, and it creates a hard thing. So something we were thinking about was actually taking a mold of the crochet and casting it in metal. I also started to look at some precedents for sculptors that had worked with fabric or line or string in a way with hard surfaces. So this is an example, Nam Garbo from 1890 to 1977. Really, these are made in the era of 1930s to 1960s, where art and engineering really were having a conversation. So you can see a similarity of bridge building, cables, and then the steel structure. So we shared this information together just to see, how these kind of things might come together. Another artist working with string or weaving or textiles. So I kind of started with a broad umbrella and working it into this very specific hyperbolic plane crochet was something where we had a lot of discussion. Barbara Hepworth also working with this idea of stretching lines. And there is math here in a certain way.
Cool. And so our collaboration together was to think, like Coral was mentioning, doing casting, right? So the idea was I could crochet first and then we could cast it in metal, but then thinking about the scope of that, how it could actually become a larger object working in the confines that we had. And then also thinking of the aim that this was to create a byproduct within 1 year. So keeping in mind how long it takes to crochet the piece and the materials and also the budget we had, how much money we had to work with. So on the right here is a picture of cast yarn. And then on the left is again that piece from my previous bridges to show again that idea of, okay, how does this become a chair? And so within that, we researched other types of string type chairs, thinking, do we want it hanging? Do we want it stationary? Do we want it outside, inside? Thinking about all these various aspects within our research. And the other aspect too was, what was I going to crochet? What was I actually going to take? Because yarn as a whole doesn't get that thick. I have got one model up here you're welcome to come look at afterwards. But I took 6 strands of basic yarn and crocheted at the same time to try and think, okay, how do I make this bigger? And so what we resolved upon was doing paracord. And so this is this one, actually, I think. Yeah, this is the 20mm one. The actual model we followed, the 18 is there, and we've got some more pictures. But crocheting with the paracord. Paracord comes in 1,000 feet spools. So that was very helpful to know we would have enough to work with and not have to have a ton of join points in order to get the length that we needed. I normally work with a 5mm crochet hook, which is the purple one. The one I ended up using for this project was a 20mm. So this one, a lot bigger, a lot scaled up, and it was nice knowing these things already existed, but those were some of the questions we were considering in getting this set up. So the hook size trials, I took an 18mm hook, a 20mm hook, and a 25mm hook, and created these 3 models to decide which hook was going to be best suited. We ended up going with the one in the middle. The 20mm was going to be rigid, but not too rigid, comfortable, but not too floppy, in order to make this chair type. And then how would we arrange the model to make it actually something you could sit in? The vision of being something you can sit in was also my concept was, again, like making math comfortable, making something you can experience, you can be within, not be intimidated by, and also having that continued connection between math and art. So then how many rows? How many rows did we have to make in order to make a 4-foot wide sculpture? So we were going to make this 8-foot multi-person chair. Thankfully, Coral had the wisdom to convey that we shouldn't start there and instead start with a half-scale model of only a 4-foot wide chair. That's all we were going to do. And so the Marquette version, that's what we called this 20mm one we made in the beginning, that had 5 rows, and it was about 10 inches wide. So 2 inches, right, is contributed to the diameter for each of these rows. And so if I wanted a 4-foot wide end piece, that's going to be 24 rows. We just made it 20 to make the comparisons easier in order to figure out what ratio we should use. Okay, so that's the next thing to discuss. The Marquette version, it has 96 stitches in its final outer row. Okay, and so I went in and set up all these Excel formulas and wanted to sort out which ratio should I use. So the Marquette, I increase on every single stitch. If I did that for the 4-foot wide piece, it would have 6 million stitches in the final row. That's not the one I picked. And from there, the 1-to-2 ratio, increasing every other stitch, that was going to have 18,000 stitches. That's still not sane. Okay, I'll go to the 2-to-3. That would have 2,000. Okay, still not possible. The one we resolved upon was the 3-to-4, which had 571 stitches in the last row. Okay, I also put the 4-to-5 ratio up there to show we didn't want to go even further apart, because then we'd have about as many stitches in the last row as we had in the Marquette version. So that would have actually made just a flat circle. And that's not the goal here. We wanted a ruffly, wavy, funky thing. And in terms of practice, one thing that I found worked well in order to not have to count 1, 2, 3, 4, 1, 2, 3, 4 in order to do the increase on the 4th stitch, I used carabiner hooks in order to mark every increase point on the piece. And so I would just do single crochets for 3 and then do 2 single crochets in the same spot on that 4th one to have this increase rate. Okay, so the Excel file, right? Okay, so I've got a little bit of this. The ratio I chose was the 3-to-4 in order to have a reasonable amount in that last row. And what I wanted to highlight with this was how we found it. So I explained before a bit of adding 2 stitches, 2 stitches, 3 stitches, 3 stitches. And then as you go, if you notice over here, once we get to the 9th row, we're already adding 10 stitches. When we get to the 20th, or sorry, no, the 14th one, right? We're adding 30. And so the amount you're adding increases as you go. getting up to the point of the last row, we're adding 114 new stitches for a total of 571 in that 20-rowed circle. Okay. How much paracord was this going to take? What did we need to buy to make it happen? One stitch takes about 9 inches of paracord to make, and we did purple and gold, of course, together at the same time in order to make this. And so the total number of stitches in the whole piece was going to be 3,200 stitches, and that equated to 2,400 feet of paracord. Again, thankfully, they come in 1,000-foot spools. This is one of them. So we were going to use that. But then in practice, and this was a continuing conversation Coral and I had, that you can calculate as much as you want, but sometimes it doesn't happen completely that way in life. That we ended up using 3,200 feet of cord. So thankfully we had extra. We used more than we expected. And my theory on that was, as I was working more and more and more, my stitches got looser. And so I used more cord. And so it's that calculation versus that reality of how much you do in practice. Okay, and then when I got to the 20th row, it wasn't ripply enough. I wanted it to wave more. And so the very last row, I just increased on every single stitch to make it really wavy and pretty, which was a big moment for me to just make an artistic decision rather than a mathematical one. I really questioned myself, but I learned, yeah, so much from Coral in that. Cool, okay, then how long did I spend doing it? I totaled 50 hours approximately of crocheting to make this piece. The last 2 rows alone took me 29 hours. That was my spring break 2024. All right, back to Coral.
Yeah, so part of that design process, as Elizabeth says, we're challenged with using pure mathematics. But also there's the human hand of actually some crochet. And one of the reasons that Elizabeth did the crochet herself was to keep that continuity of that same motion of the stitching. So there wasn't too much variation in the actual crochet. But then we have this paracord, which actually we also chose because we wanted something that could possibly go outside. So that was one of our reasons for choosing something that was really strong. We can have an interior, exterior. So in future projects, we know that paracord works really well. And we're going to hang some of it outside and see how long that weathers, one of the models. So then we came to a place where we had to start putting these together. And I started trying to calculate or interpret what this edge would be like, this frilly edge whilst it was being made. So I made some very rough sketches and started playing around with the steel, finding a steel that's going to be strong enough to hold this crochet, because as it was being made, it started to get really heavy. I mean, I don't know if we weighed it.
Oh, we didn't actually weigh it. My approximation would be I think it's probably somewhere in the ballpark of like 30 pounds of crochet. Yeah, in terms of like thinking of picking up my child who's 40 pounds and picking up the project, like I think, yeah, about 30.
So the crochet itself was about 30 to 40 pounds. And then we're talking about having somebody sit in it. So, you know, these are the different types of steel that you could choose from. We wanted something that would also be aesthetically pleasing and not necessarily jarring with the crochet. So initially I was thinking, okay, maybe I can weave the steel. But we ended up going with this 1/2 inch to 3/4 inch round stop. Because it kind of complemented the paracord in a way.
And one tiny thing I want to put on the slide was this this contraption right here.
Yeah.
Coral came up with in order to allow the string to just roll, the paracord to roll as we were going. That was a huge help.
Yeah, so making custom tools for that. Combining these materials, thinking about the hot and the cold as we're welding and grinding. we kind of had to have the crochet off to the side and then bring it in when it was full to test it. So it was kind of awkward at moments to, you know, it was a little bit frustrating sometimes, like we can't just put this on. I think I'll go to the next slide. So we started to work on the steel together. It was really great opportunity to do some skill sharing, looking at welding as sewing, doing the bending, doing the grinding, cutting the metal. So this is down in the metal fab shop. So we spent quite a few sessions there. We had to fit this in between our teaching and everything. We set up a production line to create the hooks. We custom made these hooks that would, we had to grind the end. We have some of the hooks here. So in order for it not to cut the paracord as people sit on it, we have to consider all of those kind of functional aspects. Each of the hooks is rounded off by hand, and then they're coated in a rubberized paint, so they won't rust and they will stay with the paracord. So this is what we were talking about, this idea of calculating the circumference of something that is really hyperbolic. If you calculated the actual hyperbolic circumference, it would probably be about 30 feet.
Yeah, a lot more steel.
With this waving. So also with the steel working, we're putting the steel rod through a roller, which we roll by hand. And so it's very interesting. It's like, yeah, this is mechanical, but it's also very much custom. So we rolled about 3 or 4 different circumferences to actually discover the correct circumference, not only the correct circumference for not only the chair, to have the right tension of the crochet and enable someone to sit in it and hold that. So there was a lot of to and fro with that part of it. So we actually have the object that this is, we call it the prototype. So this is the prototype, and you are welcome at the end of the talk to come and try it out. You see that big deal?
Oh, what about the same one?
And you can see the ruffles, and actually the hooks can actually unhook. So we call it a sit-in sculpture, because actually you can play with it and unhook parts and actually make a sculpture with the crochet itself as well. Oh, I want to move that on. Can you move it?
There we go.
So we did a photo shoot of it as well. This is Selva Richard's son. I do have permission to show. But we're hoping to find a place on campus where this can be shown, but also sat in. It could be a photo opportunity. With that was, you know, although it's not this 8-foot sculpture, it is. We have ended up with a functioning prototype.
Yeah.
So these are our, these are our photo shoot. You can see how you can play with the crochet hanging down. So you could actually move this around and have some different display techniques. I mean, I'd like to try and maybe build another structure.
Yeah.
Now we've got all of this stuff. We can actually build another structure that you can make it into all the sculpture as well. Yes.
I think we skipped the graph. We'll switch back to that. So
yeah.
on the top there of the piece, we ended up installing this graph that represents the number of stitches in every row. And so I scaled the very last row, which had 1,142 stitches, to 18 inches. And so then the next one, where it's half as many, is 9. And then we've got our checklist shown here of each of the sizes we had going down. So having that visualization of the exponential type growth of the number of stitches as it increases up. Oh, and then what's next? Yeah, right.
Conference.
Yes, so I'm planning to submit one of the pictures that we took of this to the next Bridges conference, which is this coming summer. I won't be traveling with that on a plane because it's near Amsterdam, I believe is where it is this year. But submitting a picture of it, and then also planning to apply to give a talk at the conference about our experience of making this and creating this sit-in sculpture together. So that's kind of my what's next. And I still have the dream of making the 8-foot version.
Yeah.
We just need more money and time and resources to make that a reality.
Yeah.
And also thinking through the logistics.
Yeah, and I think what we learned through the process is this really beautiful combination of math and then spontaneity and building something together that can change over time. So this is a little bit more about the Catalyst grant. Individuals interested in supporting future collaboration can contact the Dean of College of Liberal Arts or the Dean of the School of Art and Design. We actually used our budget to buy materials and also support some of our time. I think we've got $4 left. So,
We're very efficient with our budget.
And we've got some paracord left.
Yes, we do.
So there is, I think it was a really great experience to do something like this. Kind of takes you out of your own discipline. So
yeah, and I had never even been in a metal fab shop before this project, so really cool with that. And applications are actually open right now for CLS faculty and School of Art and Design faculty to apply for a Catalyst grant. They are due October 1. Yes.
Did anyone have any questions? Yeah.
So if you wanted to do a cast of a hyperbolic plane, would this be a good pronouncement? The situation is way too much work. Like, but how would you perform?
Well, not with the paracord. You would want to do it.
Oh, so the question was, could we actually take our hyperbolic plane that we made and go ahead and cast that in metal? Or are there limitations within the casting?
Yeah, and your exact question was whether you can burn it out. Or... Yes, you would make a 2-piece mold and then you would take the crochet out and then you would pour into that. Yes.
So the question was, thinking of the longevity of the sculpture, is it machine washable? I have not tried. I'm scared to. There are actually already some bits of like metal fibers from us having it in the fab shop. And I just had to not focus on that. In theory, yes. But I have the mini versions. We could try that, try washing those and see how that goes. But yes, and that was also part of having the hooks, was the idea we could take it off, we could mend it, we could, in theory, wash it.
I think you wouldn't want to put it in a machine.
Yes.
You could wash it like a carpet, so you could close it down. You'd sew the scrub it. So it's more like an outdoor furniture. It's everything.
About possibility of taking the ramps to that. Is it not possible to make a frame that came apart? That you could put it in pieces and then reassemble?
So the question was, in taking the chair to Amsterdam, could we make a frame that could be taken apart and then put back together again? That's a very good question. I don't know. I hadn't thought about making a collapsible frame. My concern would be getting all the hooks through TSA as well. I don't know how that would go.
I mean, you could ship the hooks. Sculpture internationally. Now we've got the design. You could actually find a fabricator in Holland that would make the steel work. And then you'd have one over there already. That's kind of cheaper with shipping these days to actually get one made.
Yes. Yeah. So the question was whether there were ways to work around the physical labor of it. I've thought about that a lot because I was getting like hand cramps working on this thing and had to like learn different stretches to like work my wrist out. So some thoughts I've had on terms of spreading it out would one just be having interns or some kind of group that crochets this together and maybe even having, because each person has their own gauge that they create with. And so maybe having varying hook sizes that each person uses based on their own personal gauge. Unfortunately, like there are knitting machines that exist. There do not, to the best of my knowledge, there do not exist crochet machines. That motion is not really replicable. So yeah, it can't be per se mechanized, but in terms of the next one would take a village for certain. Yeah, and I would love to connect and make that happen. Mm-hmm. Yeah. Okay. So the question was, in what types of science and math would you actually use a hyperbolic plane and see this idea? Okay. So warning, I'm going to get real mathy for a moment. So the idea, one thing that the hyperbolic planes violate some of the key axioms of the Euclidean plane. So in a Euclidean plane, when you have two parallel lines, they never intersect. And actually, wait, nope, that's one of them. Okay, yeah, parallel lines never intersect on the Euclidean plane. On the hyperbolic plane, they do intersect. And the other one that's key is if you have the principle on the Euclidean like flat piece of paper plane, that if you have a straight line and a point off of that straight, so here's my straight line, here's the point off of the straight line, there is exactly one line that's through that point that's parallel to the second line. On a hyperbolic plane, there are actually infinitely many lines that are through that point parallel to the second line. And there's one more axiom it breaks. So it's the idea of if we take these core principles of what happens on the Euclidean plane, what sort of shape do you get when they aren't required to happen? And the other way of describing the hyperbolic plane is how like a sphere has constant positive curvature as it goes around. A hyperbolic plane has constant negative curvature, and you're fitting that larger object into a smaller space, and that's what creates the ripples. So that's like a bit of it. Yeah, other questions? Yeah. Okay.
To see it get used with concrete as an architectural site.
Cool. Okay, I'll have to check that out. Thank you. The comment was that there exists a hyperbolic sculpture. Yeah. Oh, an actual building. Wow, in Cleveland. Okay. I have to take a road trip there.
Yeah.
Other questions? Yes.
Yes. I'm still trying to imagine what a cast is. Are doing an experiment with that? And I guess I'm trying to relate it to something that was so little.
Yeah.
Like how things are cast. Is that what you were describing, sort of making this negative?
Well, it would be a foundry process. The question is, they're still intrigued by what a casting of this would look like. But basically, for any kind of metal casting, you have a pattern. Now we have the pattern. You could potentially do a casting of it. You would have to take the pattern and then make what's called a sand mold over that captures the detail. To cast something this big, you do not have you need this much metal in one shot to cast it, or you would cast it in sections. So we went with just leaving it as the crochet wrap over.
And then the question,
Once it's casted, very rigid.
yeah, how comfortable would it be? Another idea was like to do it in like sections for the larger one and make multiple copies of that. So I'd only have to crochet one piece and then be able to copy it. But we need to look into more as to how those ideas link together.
Would be a much more time-consuming process.
Other questions?
I had a ton of questions, so this was a comment. This was so wonderful, so wonderful to hear about. It was so fascinating. Really intrigued.
Thank you. Thank you. It's been a lot of fun to do. It's been really cool. I didn't even know coral before this whole thing. And yeah, it's been great to get to work together. Cool. All right. Come up. Sit in it. Check out the hooks, check out the paracord.
And see everybody next week.